Hey, Mike.
Oh, Chuck. Good to see you.
I bet I can clone your voice.
Yeah, right. I'm one of a kind.
This video almost killed me. I spent hours and days trying to figure this out, how to clone a voice. Because here's Terry, my new AI voice assistant. Terry's amazing, but he sounds like this.
The current weather is sunny with a temperature of 88 degrees.
And I want him to sound like this.
Double sun power!
And thank you to Keeper for sponsoring this video. We'll talk more about them later. So in the last video, we built this, a completely local AI voice assistant. For me, it replaced Alexa. It replaces Alexa. It's using my AI server, Terry. I built him in this video. He's rocking dual 4090s. You know what I couldn't figure out? How to give Terry a voice. And I tried. I was gonna include it in my last video, but I failed. I couldn't figure it out. But I think I found a way. Now here's my mission for this video. I want to clone a voice. And by the way, I'm gonna show you how to do this. And yes, there is software out there that makes it easy to clone a voice, like ElevenLabs. But I hate that because it's expensive. Also, it's in the cloud. So I want to clone a voice with local and open source software. And I want it to be completely free. So after hours and days of blood, sweat, and coffee, I figured out a good way to do this. Now this right here is intense. We're gonna be training a voice using AI and neural networks. I learned so much in this process and it was incredibly fun. So come with me. Now, disclaimer. You can't just clone a voice and use it for whatever you want. So for example, in this video, I'm gonna show you how to clone my voice from my YouTube videos. I'll also show you how to clone your voice. So I'm giving you permission to clone my voice, but you cannot use my voice for any commercial purposes, to produce any content, and don't distribute it anywhere. And that goes for any voice you make. But I would love to be your voice assistant. That'd be so fun. Now, asterisk, this is not legal advice. Just keep everything local, and if you have doubts, consult with a lawyer. Beyond that, here's what you need to do this. Really just a computer, Mac, Linux, or Windows. Now, because we are training an AI model, if you have a GPU, use it. But a CPU will work. It'll just take a little bit longer. And by a little bit, I mean a lot. Now for this, I'll actually be demonstrating a few GPU options. I'll show you how to do this in WSL, on a laptop actually, rocking an NVIDIA 3080. And then I'll show you how Terry can train his own voice, my dual 4090 AI server. And then I'm gonna spin up one in the cloud. I'll spin up a GPU-powered AWS EC2 instance. And it's just fun to see how these compare. Also, you can try this right now, no matter what kind of hardware you have, because the cloud, it's all up there, ready for you to use it. But it's not cheap. Now what's great about this is we're gonna be using a software called Piper TTS. This team is amazing. And we're gonna use this to train a voice that will be put into a standard format called Onyx. This model file, this voice, can be taken and used anywhere for whatever you wanna use it for. So you can put it into a voice assistant and produce whatever words you want, whatever sentences. Or you can load it into any other TTS program or text to speech. This is why I love doing this local and open source. You get more power and it's private. And by the way, if you do wanna use your voice for your local AI voice assistant, but you haven't built one yet, go watch my last video where I show you how to do this. Anyways, let's get to step one. The first thing you have to do with any AI project is make sure you have good, clean data. And because we're cloning a voice, we'll need lots of examples of a voice we want to clone. Now, if you want to clone your own voice, there's a really fun solution called Piper Recording Studio. This makes it pretty stinking easy. The other option is to find a bunch of content that you can pull voice examples from. So for example, me, if you want to copy my voice, clone my voice, you'll need to download audio files from something like a YouTube video, my YouTube videos. Now I will show you how to do that, but what I'll also do is give you access to some of my audio files. They'll be at the link below along with all the documentation and steps to accomplish this thing, which is insane. Took me forever. I gotta keep harping on that because first, I'll show you the Piper Recording Studio, and I'll be demoing everything on my Alienware laptop behind me. I'm on it right now. The specs on this, let me go grab it real quick. GPU is a 3080. So from here, I'm gonna launch my terminal, and I will be using WSL, or the Windows Subsystem for Linux. If you're like, Chuck, I have no idea what that is, I've got a video on that right here. Go check it out. Also, you'll wanna have that already installed. Now right now, I've got nothing running in WSL, no machines. So I'm gonna install one right now by using the command WSL-install, and I'll use the Ubuntu 22.04 version. We'll create a username and password and be on our way. And we're in. Now, whatever system you're using, let's make sure we do a sudo apt update. Next, we'll clone the Piper Recording Studio repository with this command using git clone. Hit enter and it'll pull that sucker down. Then we'll jump into our new directory, cd Piper Recording Studio. Now we're gonna create a Python virtual environment using the command python3-m venv, and then the name of our virtual environment, we'll just name it .venv. Now Python virtual environments are awesome because they keep things separate and clean. They allow us to install stuff, different versions of different softwares, and they won't interfere with other projects we're working on. Essentially, they don't step on each other's toes. Now with this command, we're specifying a module called virtual environments, and then we're naming our virtual environment .vnv. That dot's gonna actually hide it. Kind of a fun little thing we can do. Ready, set, go. We actually don't have it installed. So if you don't have it installed like I do, it'll give you the command right here. So we'll snag that real quick, do a little sudo action right in front of it, and install Python virtual environment, yes. And now if we up arrow twice, we can run our command, and it did it. Now our virtual environment has been created. Now we're gonna jump into that by doing source. We'll specify the virtual environment, .vnv, then we'll do a /bin/activate to jump inside. Boom, we're there. We'll know that when we see the venv at the very beginning of our prompt here. Now we're gonna upgrade pip with this command, python 3-m pip install upgrade pip. Again, all commands are below. And then we'll install all the requirements with this command. Looking at the requirements.txt file to install everything we need. Little coffee, oh wait, that happened really fast. And now with one command, we can run the sucker. Python 3-m Piper Recording Studio ready, set, go. This is actually kind of fun. It's gonna be running in a web interface on port 8000. So all you have to do right now is launch your web browser, doesn't matter which one, and we'll navigate to localhost port 8000. And there it is, the Piper Recording Studio. We'll choose our language, where's English? And then click on start recording. You'll want to enable your microphone. And because I'm accessing this remotely, I imagine that's why I'm getting that error. But essentially you'll go through and just say these phrases it gives you. Actually, let me show you on my local machine so I can demonstrate that. I think there's a dishwasher in the apartment, and then we'll hit S to upload. And then you keep going. You can go for like 1100 if you want. The more you do, the more accurate your training will be, but the longer your training will take. Now, I already had Mike, one of my video editors, do this process. He did about 200 voices.
Hello! Would you like to move into an apartment with us? It's worth millions of dollars! We are very good friends with Sophie and Julia. Where are all the labels? Yes, honestly, I'm still thinking.
We're gonna train his voice here in a minute. Now you'll hit Control-C in your terminal to stop that process, and it's gonna live inside a folder called output. We'll jump into CD, output, type in ls here, jump into our language, NUS, that's a folder. ls there. We're gonna go one more deeper into folder 3000 here. If you type in ls, you'll see all the recordings along with the text. Now there's one more step we gotta do to make sure this data is nice and clean for us. We're gonna use this command. Actually, first we gotta make sure we have ffmpeg installed. So we'll do a sudo apt install ffmpeg. This is an amazing tool that allows us to manipulate videos and audio and do all kinds of fun stuff. We'll make sure it's installed, and then we'll use this command to export our data to a nice format that Piper is gonna look for when we train our AI models. Command will be python 3-m, and we'll specify a module. It'll be export underscore dataset. We'll then specify where all these files are. Mine are right here in my home directory. It goes in Rec Studio, Piper Recording Studio, output, and we'll leave it at language. And then we'll specify our output directory. Mine will also be in my home directory in Rec Studio, and I'll name it my-voice-dataset. Ready, set, go. And make sure when you run that, you're in the root folder of Piper Recording Studio, so it can find that module. And if I look inside that folder, I can see that I have my voice dataset directory. And if I jump in there, I have two files. I have a metadata CSV, and then I have a wave folder. This wave folder has all those audio files. This metadata CSV is actually really fun. If we jump in there, let's do a less metadata CSV. This is the name of your audio file along with its transcription right next to it. Now I'm showing you this right now because Piper is gonna want this format to train. A folder called wave full of audio files and a metadata CSV. The Piper Recording Studio helped us do this like that. But for another voice, like maybe my voice from YouTube, there's a bit more involved. Let's walk through that right now. And by the way, if you want to jump back out of your virtual environment, which we'll do right now, just type in deactivate and you're done. I'm gonna jump back into my root directory. So now our goal is to clone another voice, and we need to download some audio samples, audio files. If you're trying to clone my voice, the best resource will be YouTube. Shoot, even try downloading this video. But sometimes YouTube may not like that, so I'll provide the audio files below, a WAV file, just download them. Now real quick to make things clean, I'll make a new directory, mkdir, and we'll call this data prep. Then we'll jump in there. Inside this folder, we'll create a new Python virtual environment, python 3-m, venv, and then .venv, that's our name. And then we'll activate that, source.venv/bin/activate. And we're in. Now to download a YouTube video WAV file, we'll use a tool called ytdlp. We'll use this command to install it. Pip install yt-dlp. With it installed, use this command, yt-dlp. We'll say -x and then --audio format, audio_format. We'll say we want it to be a WAV file, and then we'll specify the YouTube video. Let's go find one real quick. Go to YouTube. Say NetworkChuck. Now, whatever voice you're gonna clone, make sure it's a clean voice. No background music, no people interrupting. This can be hard to do. For me, I talk a lot. So let's see, my time server video, 28 minutes of me talking. Let's grab that, share it, copy the URL, paste that right in here, and go. Oh wait, audio format was not underscore. It's supposed to be audio dash format. There we go. Oh wait, I need to install ffmpeg. Pip install ffmpeg, and then we'll try it one more time. Okay, didn't like that. I'm gonna try installing via apt ffmpeg, and let's try it one more time. There we go. It was looking for a local install of ffmpeg. ffmpeg, it's hard to say. Type in ls, there's my file right there. Big and messy, I hate that. I'm gonna move that to a easier file name like chuck1.wave. Perfect. And then we'll do one more video, because the more data you have, the more accurate the voice. Now let's do a private AI video, and we'll rename that one chuck2.wave. Type in ls, we should have 2 files in there, chuck1, chuck2. Now these files right here, Piper's gonna hate that. They're 15 to 20 minutes each, and Piper wants them to be no longer than 15 seconds each. How are we gonna do that? We're gonna have to use some Python magic to divvy up these files to be 15 seconds each. Also, these files aren't very clean. There is some music at the beginning and end. We're gonna take those out. So first, let's edit our files, make them clean. We'll use a tool called Audacity, which I don't think I have installed. I'm gonna go find it real quick. It's an open source tool for editing audio files. I'm gonna open up my Windows Explorer in this location. Explorer.exe, then I'll put a dot after that, and I'll drag the first file in there. And let's see what we got. I'm installing a time server in my studio. All right, so we'll get to the part where there's no music, and we'll just take pretty much all of this. So financial trading sounds better than NTP. But I meant my hack that, yeah, no music till the end. So we'll just take the entire thing right here until the end. File, export audio, export to computer, and then this is important right here. We'll name it Chuck1. No music. We'll put it in that directory we were in WSL. We'll change the channels to mono. We'll change the sample rate to 22050. Encoding's good. We only want the current selection and wave format. We're good to go. Hit export. We'll close this one and do the same thing to the other file. All right, I've got my no music files. I want to remove my with music files. This RM Chuck1, RM Chuck2. Now we're gonna do one more thing to clean these up, and that's remove any silence. For that, we're gonna use ffmpeg. Very simple to do this. I'll have this script below. It's gonna look at every file here in our directory and remove the silence. Ready, set, go. Done. Now I have 2 new files, Chuck1, no music, no silence, and Chuck2, no music, no silence. Let's remove our old ones, and I do wanna make sure they sound okay. A day goes by. I'm actually kind of worried about that because I have my antenna in my server room, Grandmaster, and then forwarding a Perfect. Now we're almost there, but we have to take these 2 files and cut them up into a bunch of little files that are no longer than 15 seconds. Thank goodness for bash scripts. But before we do that, let's take a quick coffee break and talk about our sponsor, Keeper. They are helping us with a massive problem because this guy, Demercapi, revealed at DEF CON, a hacking conference, that he found at least 15,000 developer secrets hard-coded into software. These are things like passwords, API keys, authentication tokens, just sitting there, ready for someone to get them. Developers and admins keep leaving their stuff exposed. What do we do about this? Keeper is a privileged access manager for stuff like this. Now, this isn't a normal password manager, even though they do have that as part of their Keeper PAM solution. But where I get excited is this thing they have over here, the Keeper Secrets Manager. This thing is crazy. It makes it easy for people like you and me, developers, security admins, people who are in the terminal a lot. It helps us to manage our passwords and secrets and actually do a good job at it. And they meet us right where we are. In the terminal, you can use this password manager from your terminal. I'll show you that here in a second, but just know that Keeper, it's fully cloud-based, meaning you don't have to worry about hosting it in a VM and doing some complicated infrastructure. And it's also a zero-knowledge platform, meaning they have zero knowledge about your passwords and your secrets. Unlike this guy, Demarc API, or whatever his name was. You can use Keeper Secrets Manager with pretty much anything. Ansible, AWS, Docker. Stop hard-coding your stuff in Docker files. But what I want to show you is the terminal access, which is so stinking cool. I'm gonna log into the Keeper shell, and this is decrypting my vault locally. There's a lot of encryption and decryption with Keeper, and I can manage my passwords and secrets from here. Let's add a new secret. There it is right there. And then the way I can use this API key is insane. I'll create an application and then give it access to just this one folder. I'll then generate a one-time access code. With that code, I'll authorize myself and get this file. And then in my script, which I'm gonna use to pull down my latest YouTube comment, when I'm specifying the YouTube API key, which I'll need to actually ask YouTube for that comment, I'm not specifying the key anywhere. Instead, I'm interfacing with Keeper, securely connecting to my vault and grabbing this API key. Let's try it out. Notice no API key hard-coded here at all. There it is. And this is just one example of how you can use Keeper to keep all your stuff safe. So go out to keeper.io/NetworkChuck. If you sign up for the demo, you'll get 1 year free for the Keeper Password Manager Personal. But seriously, this is a very cool product. Thank you to Keeper for sponsoring this video. And now, back to the video. And actually, what we'll do real quick is make a new directory, call it wave, just like that. I'll paste in this for loop. Ready, set, go. Woo! Let's ls our wave folder, see if anything's there. Yes, there they all are. I do want to play them to make sure they're actually real files. By default, our NTP server is time python.windows.com. Perfect. And I know I keep saying we're almost there. We are almost there. But now we have to take all those files and transcribe them. And this step is just kind of nuts. I love this so much. And then take that transcription and put it into a CSV file that matches up to the column of the file name. Thank goodness for Python. Let's make that script right now. I mean, make it, I've already got it. But first we have to install Whisper. We're gonna use Whisper to transcribe all these audio files. It'll be using local Whisper. We'll do pip install Whisper. Give that a second, we'll take a little coffee break. Okay, Whisper is installed. Now we're gonna create a new Python script. Commands will be below. Type in nano, whisper something to me, .py. Paste in the config, Control X, Y, enter to save, and then we'll run our script. Python 3, whisper something to me, ready, set, go. Now this might take a moment depending on what you have going on. If you got a GPU, it's gonna use that GPU to process all those transcripts. Let's go monitor my GPU performance right now. Yep, there it goes. And right now it's opening up every file, transcribing it, and then it's gonna output it to a CSV file. This is pure magic. And it's done. Awesome. Let's go take a look at it. I'm so excited to see this. Type in ls, there's our metadata CSV. Let's open that. And there it all is. That's awesome. Okay, cool. So now in this directory, all we're gonna want now is simply our wave directory and our metadata CSV. I'm gonna delete everything else. Nice and clean. Data prep, no matter what path you chose, is done. Almost. I'm gonna deactivate my Python virtual environment and get back to my root folder by typing in cd and space. From here, we're gonna make a new directory to make things nice and clean. We'll call this training, and we'll jump into training. Inside here, we're gonna clone the Piper repository. Ready, set, go. And then same story as before. To keep things nice and clean, we're gonna set up a Python virtual environment. Python 3-m VNV, then we'll name it .vnv. And then we'll activate it, source.vnv/bin/activate. Perfect. Now, what we're about to see is where a lot of my headaches came in. While Piper is incredible, it's working with some older libraries that don't work with modern stuff. Now, I don't know why that is. I think it's been updated, I'm not sure. But here's a few things we gotta do right now. First, we have to make sure we install this very specific version of pip, 23.3.1, just like that. Again, commands are below. Then we'll install a very specific version of numpy, just like this, 124.4. And then we'll need a very specific version of torch metrics. Now, the reason I'm doing all this is it will throw errors, it'll screw you up. I almost pulled my hair out and my beard out, and this is not the only thing. Hey, Chuck from the future here. You may want to install torch metrics, this command we just did here. Do that after we do pip install -e. It won't hurt anything to do it before, but it'll save you some time. Okay, let's install this, torch metrics. Now, a lot of this stuff is pretty heavy. I hope you have a good internet connection. But hey, more time for coffee breaks. Finally stinking done. From here, we're gonna jump into Piper, cd Piper, then jump into source, and then Python, just like that. Now, real quick, this is where it murdered my soul, and thank you so much to this person, LPSCR. If you have a 4090, like I do, both on my main computer and running in Terry, he's got two 4090s, it would run into an issue, because it was running CUDA 11.7, that's what was required for this project, and 11.7 has a bug in it to where it just doesn't work with 4090s. Oh my stinking gosh, I tried a million things. You have no idea. But like most things in tech, the solution is elegant and simple. Change the requirements file, along with installing this PyTorch version, if you have a 4090. If you don't, it should work fine. So just keep that in mind. I'm so glad I found that. I almost cried when I saw that. But anyways, we're here. We're gonna do some wheel setup with this command. And then we'll type in pip3 install -e and then dot. It's gonna install all the stuff we need based on the requirements. Ready, set, go. All the prep work we just did should avoid all of our issues. Okay, no errors. Oh my gosh. That is so beautiful to see. You have no stinking idea. Okay, now we're gonna do one more thing. There's a script in here called build monotonic align.sh. We're gonna run that, /build monotonic. Go, should go with no errors. Oh, and we're good. Yes, you have no idea how amazing it is to get to this point with no errors. Now we're almost ready to train, but not quite yet. There's just a little bit of data processing we have to do right now. Don't worry, it's super easy. All we have to do is use this command. This will all be below. This command will run a Python module, piper train.preprocess. Before we train, the input directory will be our data, which we have in data prep. This was the data that we just formatted, the metadata CSV and the wave. Now, if you did the Piper Recording Studio, you already have this folder and all you have to do is point to that folder. And then you'll specify your output directory. I'm putting it in my training folder, the one we just created together, and then I put a new folder in there called train-me. This will actually create that folder. Don't worry about having to create it. The rest of this, all default. Let's run this. Ready, set, go. This might be a little intensive. It's gonna be using 20 workers based on the number of CPUs I have, CPU cores, and 177 utterances. I don't know why I had to say it like that. Felt like I had to. You can hear the fan turn on back there. It's really cooking. Shouldn't take too long, depending on what you have. And that is done. Okay, now I'm gonna list that directory, ls. It was in my home folder inside training. There's the folder, train me. I'm gonna ls that real quick. And inside these files are everything Piper's going to need to train our new voice, which this voice is gonna be my voice. I'm so excited. I can't wait to see what this does. It just hits different to use something local on your own hardware, doesn't it? Way more fun. Now time to train, this is the tricky part. But before we do that, we have to download a starting point. Let me show you what I'm talking about. We don't wanna start training from scratch. You want to fine tune an existing model, one that's already laid the groundwork for you, and you're just gonna fine tune it. So think of like just a regular, normal, unexciting voice. You're just gonna put your voice data on top of that, and you kinda got a head start, you know? It's like a relay race. They've already run 3 times around the track, they're gonna hand you the baton. That's what an existing model is gonna do for us. Now what that means for us is we gotta download that model. I'll have a link below, and by the way, this is the training guide on the official Piper TTS GitHub. It's great, but I filled in some blanks for you. So I'm gonna right click that and go to an existing model, choose English, US English, and we're gonna choose LESIC. Now here you can choose your quality. High is gonna take longer. Medium, low, you got the picture. We'll choose medium just to keep things simple. And we're gonna download this file right here, a checkpoint file. This is our head start. You'll see what I'm talking about here in a second. Let's click on that, click on the copy download link right here, and then we'll jump back into our terminal and we'll just save it right here where we are. wget that file. It's gonna download it from Hugging Face, the absolute best company name I've ever heard of. It's so sweet, isn't it? It's just nice. Awesome, checkpoint file downloaded. Now, we are ready to train, my friends. Couple of things to note that you might wanna change for your specific situation. First, my dataset directory. Where's that training data? It's this folder we just made. Mine is called Train Me. It's gonna be the resulting folder from our step we just did, the pre-processing. Next, we have our accelerator. I have a GPU. So I'm saying, you know what? Use a GPU, please. If you don't put that, you don't have to run the accelerator command. It'll just use your CPU. Then you can say, hey, I've got one GPU with the --GPUs command. And then our checkpoint file right here, resume from checkpoint, resuming from our head start. That file lives right here in the current directory we are in. That's the name of it. And actually this quality right here, because we're using a medium quality voice, I'm gonna change that quality to medium. And actually, okay, I keep saying we gotta change more things. I built this script for my dual 4090 GPU setup. This strategy-DDP, we don't need that. If you don't have 2 GPUs, you won't need that at all. So we'll just take that out. Now, a couple of things to tweak your training. Batch size. We have it set at 32, which may be good for my 3080. This all depends on the amount of RAM your GPU has, the amount of VRAM. If you get an error like, hey, we can't handle this, we'll just decrease that to 16, 8, 4, 2, as low as you gotta go. Then right here, max epochs. An epoch represents an entire pass through the data set. So in our case, we have 177 utterances. One pass is going through every one of those. And we're saying right here in our configuration, we want you to do 6,000 rotations, epochs through our stuff. But hold on, we're actually starting at epoch 2164. So what you're gonna see when we run this is it's gonna start at 2164 and work on 2165. Now, if you want more quality, more iterations, you can increase that number. Shoot, double it, make it 1200. Keeping in mind, you increase the epochs, you increase the time to train. Now, fingers crossed, this should work. Let's go ahead and run this. Ready, set, go. Okay, it's figuring things out. Fingers crossed we have no issues. It'll give you lots of possible warnings, just you'll be okay. And it's moving. Oh, okay, yes. You see what's happening here? And actually, it's moving kind of fast. There's the steps. It's chugging right along. 2171, 2172. That's how fast we're making those rotations going through the epochs. If I go to another window of this same WSL machine, type in NVIDIA-SMI, I can view utilization. Actually, I'll use the command watch-n 0.5 NVIDIA-SMI, so it auto refreshes. So yeah, there, that GPU is going a little crazy. Actually, it's not being hit too hard. I could probably increase whatever's happening there. Now check this out. If for whatever reason, you want to stop the training or pause it or whatever, you gotta go or you gotta turn off the GPU, you can do that and resume right where you left off. So check this out. You're gonna hit Control-C. Whew, scary. It's okay. And to resume our training, we're gonna go look at our latest checkpoint. And it's where our training folder is. So I'm gonna go to my training folder, jump into Train Me, that's where I put that. And then I'll jump into what's called Lightning Logs. Sounds like amazing logs. Then we'll jump into whatever our latest version is. You might see version 1, 2, 3. We'll jump into version 0, ls that. And then we're gonna jump into checkpoints, cd checkpoints, ls that, and there is our current checkpoint right there. All we have to do is reference that file as resume from checkpoint, this spot right here. So let's do that. So this is our location. I'm gonna jump back into my Piper directory and run our script again with our new checkpoint right here. Ready, set, go. Oh wait, I have my command wrong. I had a period in front of that. Home. This does take quite an attention to detail. Now let's try it again. And we're moving and grooving. Again, it's going pretty stinking fast. Faster than I expected for a laptop. So that's training my voice. I'm gonna go train my video editor Mike's voice on my dual 4090 machine, Terry. All right, I've got Terry all ready to go. And actually, I'm gonna have Terry train Terry. And hey, NetworkChuck from the future here. I actually got Terry's voice from a few videos on YouTube. Primarily this one and this one. So I'm gonna paste this command in, making sure I'm using 2 GPUs. Ready, set, go. Oh, I forgot one step. Now let's try it. Actually, I want to do a TMUX session real quick. And here we stinking go. Things are moving quick. So many scary messages. I think it's working. Where's my checkpoints? Moving so fast. Let me make this smaller so we can see it better. Oh, there it is. There it is. 2081, 82, 3. Let's get out of TMUX here. Yes, using both GPUs. Ah, love it. Woo! All right, so now Terry's training Terry, and I want to train Mike's voice too. For that, I'm going to use a cloud GPU. I'll get logged into the AWS console, go to EC2 and launch a new instance. For this, I'm going to go with something beefy. A G5.12. This should have 4 GPUs. Don't do this at home. That's all I'm saying. And I'm gonna launch a, launch an image that already has NVIDIA drivers, like this one with PyTorch. Perfect. We'll call this Mic Voice. And let's launch our super expensive GPU. I think it's like $5 an hour. And we'll wait for it to come up. I just love the fact that right now I've got 2 AI models training at the same time. One on Terry, one on this laptop that's having a fit. Let's check on him. What checkpoint is he at? 3031. Halfway there, buddy. Let's make sure we have 4 GPUs. We stinking do. Let's jump into a TMUX session, run our commands to train on Mike's voice. Notice we have 4 GPUs now. Fingers crossed. Let's go. Oh, I didn't like that. Oh, forgot the torch metrics thing. See, so many little things we gotta remember to fix this. All right, with that fixed, we should be able to run it now. All right, it's getting the 4 GPUs ready. Is it working? And it's moving. Now all we have to do is wait for all of our models to train. Now I'm gonna change one thing on Terry. I'm gonna stop his training for a second. I'm gonna change his precision to 16. I've read that mixed precision on 4090s will help somehow. Let's see if it increases any speed. Resuming from our checkpoint. Seems about the same. And then on the GPU server, it's chugging along, but not as fast as I would have thought. Let's watch all the GPUs light up on NVIDIA SMI. Yep, they're all going. Now all we gotta do is wait. All right, new day, new cup of coffee. Let's go check on our models. I know they did all finish because I had to check on it in the middle of the night. I could not look at it, right? I was way too antsy. You'll know your training is done when you see the final epoch reached. I don't know why, I just love the word epoch. But now that it's done, we gotta do something with it. Let's do that right now. First, we have to export it. And essentially, we're gonna be looking at that final checkpoint. I believe it will be this one right here, 599. We're gonna look at that checkpoint and we're gonna convert that to an Onyx format. Onyx, spelled like this. Onyx is a universal format for TTS. Now, it'll be just one command, but first we have to find that checkpoint. We're gonna jump back into our training directory, which mine was in training and it was called train me, I think. Yes, if I ls that directory, you'll know it's your training directory because it has the lightning logs. So we're gonna peruse through those. And see, I have version 1 here. I'll jump into version 1 folder. Then we see checkpoints, we'll jump into checkpoint, and then there it is, epoch 599. I'm going to input that into my command, and the command will look just like this. We'll be using the Python module piper_train.export_onyx, and then specifying our lightning log, our checkpoint, and then where we wanna put it. I'm gonna put it in my training folder, and we're gonna name it model.onyx. Ready, set, go. It's gonna do a few things here, and we're good. Now, I might give you lots of potentially scary warnings. It always freaks me out. But at the end, we see Piper train export has been exported to that model file. Now, one more thing we have to do. In our training folder, the train me, it's gonna ls that directory. There's a file called config.json. We're gonna need that one too. So we're gonna copy that to that same directory where we exported our model file. So we'll copy config.json and we're gonna copy it to a file name, model.onyx.json. Done. So now if I ls my training directory, I should have everything I need for my model. These 2 files, model.onyx and model.onyx.json. Those are all we need to produce voice from our trained model. Now this is me right now, my voice. What do you say we do something with it? We actually, from this command line right now, produce something with Piper TTS. So we'll start with an echo command. We're gonna echo something we wanna say. Hello, my name is Chuck. My voice has just been trained. And then we'll pipe that into our Piper command, which will be Piper-m. We'll specify our model, which was, I'm in the training directory now, right now, so it'll be just model.onyx. And then we'll output it to a file with the output file command. And we'll just call it chuck.wave. Ready, set, go. Oh wait, we gotta install Piper, I forgot. We gotta do pip install Piper-TTS. I think that's what it is. Yes, very quick install. Let's run our command once more. And that was it. Like, it's that quick. Once you've trained the model, you've got it. Now let's play it. I'm gonna open my Explorer, find Chuck Wave. Let's hear what it sounds like.
Hello, my name is Chuck. My voice has just been trained.
That sounds so bad. Hold on. Maybe it's because it's playing through remote desktop. Let me pull it into my computer here. That was the worst thing I've ever heard. Let's try it again.
Hello, my name is Chuck. My voice has just been trained.
Oh no, that's so bad. That did not work for me for some reason. I don't know. We must have done something wrong. Hey, NetworkChuck from the future here. I tried to figure out why my voice sounded so bad. And I thought, hey, maybe it was the method I'm showing you. So I tried my pastor's voice.
My name is Johnny. My shoes cost $45,000.
So while not perfect, that sounded a lot better than I did. Then I did David Bombal.
My name is David Bombal. Subscribe to NetworkChuck and all your dreams will come true. Also, I prefer coffee over tea.
Now that one sounded great. Why? It comes down to the quality of the clips you have, the number of the clips you have, and the diverse number of things they might be saying. Also, the number of epochs or the number of times you train will impact the quality. But that begs the question, what happened to my voice? I tried. I even created this fancy Python script that found the best clips for my videos. Still, I sounded ridiculous. I think it's because I talk too fast. So instead of pulling in the clips from my YouTube videos where I'm constantly just like doing this, I did the Piper Recording Studio, and I did it for a long time. I did like 400 utterances. And here's the result right here. It's time to hack the YouTube algorithm. Hit that like button, subscribe, comment. You gotta hack YouTube today. Ethically, of course. So that sounded pretty good. Not perfect, but good enough for a voice assistant. So now you can still create my voice if you want. I will include all the Piper recordings I did, so you can follow this tutorial and create a version of me for your home assistant, voice assistant. And by the way, Terry sounds really good. A little weird, but it's that weirdness that I kind of fell in love with, honestly. You'll see here in a moment. But just keep in mind, whenever you're training a voice, the quality of the voice, background music, keyboard typing can all interfere with the quality at the end. And I think if I would have done the due diligence of making sure each clip was pristine and clean, I would have had no problems. But I'm trying to automate this, do it very quickly, so if you don't mind a janky voice, I will include all the methods I've mentioned in this video and the documentation, both the way I've shown you just now and a fancy Python script that'll do a few extra things. Anyways, back to past Chuck. Let's try Mike's voice. This was trained on a GPU server in the cloud. All right, let's try this.
Hey, this is Mike. I'm super sinister.
That actually sounds awesome. It sounds just like him. Now I'll show you Terry here in a moment. But now that we've got the file, how do we get this into our voice assistant? How do we make this thing talk? Let's do that real quick. Now all we'll really have to do is upload some files to our home assistant server. Now if you didn't watch the previous video, we had to do this. We had to go to settings, add-ons, and add a Samba share so we could easily connect to the file system of our home assistant. If you haven't done that yet, go back, watch that video. It's at the point where we taught an open wake word to our assistant so we can answer to Terry. See? So to access that, I'll just go to my search bar up here, type in the IP address of my home assistant, and go to share. It's gonna prompt me for credentials, and we're in. Here we'll create a new folder, call it Piper, and I believe we'll create another folder here and just name our voice. We'll call it Mike. And then we'll throw our Onyx files inside there, our train model. Keeping in mind, this will be using the Piper integration local on our home assistant server. And actually, you know what? I think we have to rename these files from model to just the name. So like mike.onyx and mike.onyx.json. That might be enough. Let's just go check and make sure. I'm going to restart Piper, the Piper add-on. And then we'll go into settings, voice assistants, and let's add an assistant. So we'll add one. We'll call this Mike. We'll choose Terry as the conversation agent. And for Whisper, we'll also choose Terry. And then for text-to-speech, we're gonna choose this server, the old one. And then we'll need to choose, let's see. Okay, it's not finding Mike. We might just have to move the files to the root. So I wanna move that back up to Piper. So now it's just mike.onyx, mike.onyx.json at the root of the system. That might do it. Back out, add a new assistant. We'll go straight to text-to-speech and see if that shows up. Let's try and reset the Piper once more. All right, it reset. Come on, fingers crossed, here we go. Let's see if it works. Okay, figured it out. All I had to do was go into settings, devices, go into Wyoming, and refresh the Wyoming device. So here it was, Piper old. Just refreshing that or reloading it should get us going. So we'll go to settings again, go to voice assistants, we'll add an assistant. If we go to text to speech, we should be able to select Piper old. And then a language, this is where it's different. We should see just an English option. And then it's called Do It, Train Me. That was like the folder name. We actually go in there to make things less confusing and jump into the Onyx configuration and change the name to Mike. We'll call it medium quality. That's weird that it did that. So we'll save that. We'll refresh Piper once more, or the Wyoming. Reload that, get back into settings, go to our voice assistant, add an assistant, and I think we're here, right? Choose Piper old. English. Still didn't change. I'm gonna refresh Piper. That really bothers me. Then we'll do the Wyoming part one more time. If I have to do this one more time, I'm gonna freak out. Reload, go to settings, assistant, add, text to speech, Piper old, English. There we go, Mike medium, perfect. Okay, we're about to do this. Now, what I'm gonna do is name it Mike. We'll have it be ChatGPT on Terry. I wanna give it no assist control for now, meaning it won't be able to control my home. And I'm gonna give it like, you are a sinister man. This is what Mike calls himself. Your name is Mike, are unhinged. Answer every question according to that personality. That's all I'll give it for now. And then we'll make sure speech to text is faster whisper. And then wake word. We don't have one for Mike. Just realized that. We'll just have it be Terry. And create. I'm gonna go to my Wyoming satellite here and adjust its settings. We're gonna say the assistant will be Mike. And yeah, that was it. It saved it. Now time to test. Terry, what year did The Matrix come out?
Maniacal laughter at horror. You think you can just waltz in here and ask me about some ancient relic like the Matrix? Well, let me tell you something, my dear. It came out forcing for dramatic effect 1999. But don't think for a second that it's anything more than a trivial amusement for the masses. The real world is far more sinister, and I'm the one who's gonna show you what true power looks like. Chuckles menacingly.
That's amazing. Okay, it took a minute because Piper's running on the Home Assistant here. Not as powerful as Terry. Let's try something else. Terry, tell me about Abraham Lincoln. Give it a second.
Suddenly, my demeanor changes a wand of intense fascination are Abraham Lincoln Forsing, less than 30, yes, the 16th President of the United States. A complex figure, indeed. His legacy is shrouded in mystery and intrigue. The tall, lanky man with a heart of gold, yet a mind consumed by darkness and obsession. Leaning in, my voice takes on a conspiratorial tone. They say he was haunted by the ghost of his own son's death. That the weight of his grief drove him to madness. But I know better. I've seen it all before. The masks we wear, the secrets we keep. Lincoln was just a pawn in a logic game. My gaze becomes distant, as if staring into the abyss, and then, of course, there's the little known fact about the assassination itself. Some say it wasn't just a lone gunman's bullet that took him down, forcing for dramatic effect, but that would be telling too much. Let's just say Lincoln's fate was sealed from the very beginning. My eyes snap back into focus, and I let out a cold, mirthless laugh out of horror. The wheels of history are always turning, my friend, and I'm the one who's going to show you what's really behind the curtain.
Don't you want this in your home? That's amazing! I can't wait to show the guys. Now, one last thing I want to do before I show you Terry is I want to actually run Piper on Terry. I want to put this model onto Terry. Okay, here on Terry, I'm going to run it in Docker real quick. I've got a folder called Mike Model with the model inside. I'm gonna run this Docker command and see if this works. Voice not found, Mike. Oh, I didn't change the name here, I don't think. Yeah, I didn't name it here. I'm so dumb. Okay, Mike, medium. Now let's try it. I changed it. It's called Mike. All right, let's try renaming the model. Maybe that'll do it. Remove the medium. That was it, the name of the file. Okay, that's ready to go. Let's go in here to Home Assistant and change our Piper to new Piper. Actually, I need to go refresh my Wyoming again. Piper, the new one. Perfect, it found it, update. It should be a lot faster now. It's using Terry for everything. Terry, tell me a 10-second scary story.
Maniacal laughter at horror, listen closely. My dear victim leaning in close, you shouldn't have looked at the old photograph. Now you'll never be able to escape the eyes of Emma. Pausing for a brief moment, she's been watching you and she's coming for you, wicked grin.
We did it! Oh my gosh. And now, for the final reveal, Terry, in all his glory. Okay, shh, here he is.
Terry Crews, a former NFL player turned actor, currently serving as the voice assistant at NetworkChuck Studios. How can I help you today?